Welcome back to our convocation here. This is our fifth keynote. This morning we heard from Andres Duany, who gave a provocative discourse on the lessons learned from his experiences in New Orleans and Haiti, and the complexity of cultural codes and social structures and the contradiction of the state, the bureaucratic and regulatory processes. Some very provocative ideas that he presented this morning, and I'm sure food for thought in the context of our previous keynotes. This afternoon we're going to hear from Guy Nordenson, whose presentation is titled Climate Adaptation Design. Mr. Nordenson is a principal of Guy Nordenson and Associates in New York, professor of structural engineering and architecture at Princeton University, and faculty associate of the University Center for Human Values. Nordenson was the structural engineer for the Museum of Modern Art Expansion in New York by Yoshio Taniguchi, the Jubilee Church in Rome in collaboration with Richard Meyer, architect, Simmons Hall residence at MIT with Stephen Hall, and many other projects. Nordenson is active in earthquake engineering, including code development, technology transfer, long-range planning for the Federal Emergency Management Agency, or FEMA, and the USGS. He initiated and led the development of the New York City Seismic Code from 1984 to its enactment into law in 1995. He was the first recipient of the American Academy of Arts and Letters Academy Award in Architecture for contributions to architecture by a non-architect in 2003. With Terrence Riley, he was co-curator of the Tall Buildings exhibition held at MoMA, Queens in 2004. He has served as commissioner and secretary of the New York City Public Design Commission since 2006. He was editor of 7 Structural Engineers, the Felix Candela Lectures in Structural Engineering, published in 2008 by the Museum of Modern Art. His project On the Water, the New York, New Jersey Upper Bay, won the 2007 AIA College of Fellows La Trobe Research Prize. The research was published in On the Water, Palisade Bay, and served as the inspiration for the MoMA workshop and exhibition Rising Currents, which was held this last fall of 2010. Nordenson was a recipient of AIA's 2009 Institute Honors for Collaborative Achievement and is the 7th structural engineer to receive such an award. With that, I'd like to welcome Guy Nordenson. Thank you.
Good afternoon. I was circling above the monsoon here, which coming in, so I'm glad I made it through the tornado to get here. I gather this is part of the tradition of these conferences, that you have a monsoon in the middle of your conference. I want to talk about a couple of different projects that are related under the rubric, if you will, of climate adaptation design, and a point, I think, toward an area which, given all your interests, is particularly relevant to this group, which is how we design, how we contribute to the design of communities and facilities for the consequences of climate change. This is not something that I have any particular expertise in. I'm a structural engineer. I teach in a school of architecture, and I teach engineering, and I practice as a structural engineer, so I don't have a background in climate science. But it's something that emerged, as I'll explain, as an interest, and it seemed to catch on through some research that we did at Princeton with students and with colleagues, and led to a series of opportunities and further research. So clearly, I think we hit a nerve and a need in the community, and I think that it's an important opportunity for designers and planners, and it points a way that I think we need to points to an area that I think we need to get involved in. So I'm going to talk about a couple of different projects, and the projects kind of evolved chronologically, starting with the La Trobe project, as we called it. This was an initiative actually prompted by my dean, Stan Allen, who called me one day in the fall a couple of years ago and said, you know, there's this research grant and I'd like you to apply for it. And I said, well, to do what? And he didn't have any ideas. So my wife and my wife was an architect and a landscape designer, and I started to speculate about what sort of a project we could dream up. And I had been working for a while on various projects at Ground Zero after 9/11, and projects related to the redevelopment of the site at the World Trade Center. And one of those projects was a proposal for a broadcast tower that would replace the broadcast tower that had been on top of the World Trade Center tower for the TV, the various TV stations in New York. There's a requirement that they broadcast over the air as well as through cable. And the notion that we had was to build a tall, 2,000-foot tall structure right here at the corner of this pier. These piers that stick out into the harbor, this is Manhattan, are the Bayonne piers because they're part of Bayonne, New Jersey, and they were built in the Second World War, actually under the supervision of Robert Moses' brother. Interesting detail in Caro's biography that it was the brother of Moses who, it sounds interesting, the brother of Moses, who was the overseer of this project, which started out as a military pier for the Navy to mobilize during the Second World War. And they're quite big. And so we had an idea that rather than build a tall structure for broadcast at the site, that there was some variety of reasons why it would make some sense to have a tall structure there. And in developing that project, and we worked on this with the Port Authority and a few others, it became clear, to me at least, that this was a place in the region of New York that really was under, really not that well known. It was, I mean, I grew up in New York and I'd never really thought of the Upper Harbor as a place that kind of, you know, like Central Park sort of organized the space of the region. So following up on that project and that realization, what we came up with was a proposal for a project that would look at the possibility of the adaptation of this part of the city to the consequences of sea level rise. The question being, how are we going to both replace some of the ecologies that are affected by sea level rise? How are we going to modify the waterfront as a consequence of the sea level rise? And then also, what do we do about the different kinds of storms and storm surge that will come about because of the higher sea level? So trying to combine all those questions together with this idea of making this place a new kind of place for the region. And I think there was a certain aspect to this that also had to do with 9/11, where it was clear in reflecting about the consequences of that that it was obviously not just about Manhattan and had affected everyone in the region. And so to some extent there was a greater regional awareness, I think, that was developed in part thanks to that, and of course in part thanks to the emergence of other parts of the city, particularly Brooklyn, as new centers of culture and so on. So a lot of different things converging on this idea. So we established the boundaries of our project as being this zone here. Sort of the last thing is, if you look at this figure, it reminds me at least of a figure in a Dr. Seuss story. So we grew very fond of that as well. So all these different elements coming together. First of all, the fact that in the New York area, at least, we are looking at something on the order of 1 meter of sea level rise on or about the end of this century. They're varying estimates, and the estimates keep getting greater as we understand better what's happening to the ice cap in Greenland and the Antarctic. But it's, let's say, a meter of sea level rise is likely to happen. And it has to do also with the movement of the Earth's crust as a result of glacial rebound in the New York area as well. Now, as it is today, we have flooding concerns in New York. This is a map of the flooding zones corresponding to different levels of hurricane coming through from category 1 through 4. So we already do have emergency plans in New York to deal with this, to deal with temporary housing and so on that have been developed by the Office of Emergency Management that did this map. What happens with with sea level rise is that these areas will be flooded more often. That if this, for example, corresponds to maybe 1 in 50 or 100-year return period, that you're going to see flooding because of the higher sea level. You're going to see flooding happening there maybe once every 10 years or thereabouts. So it's going to be more flooding, but also flooding more often. Now, one solution to that is to build barriers. There's a proposal from colleagues at Stony Brook, SUNY Stony Brook, to build a series of hard barriers that would prevent the storm surge from at least entering the inner harbor. And to do that, you would really only need to build a gate by LaGuardia Airport along the Verrazano Narrows and at the mouth of the Kill. I forget what this one is called, but this is the Kill Van Call, so this is the Kill Van something else coming along here. But basically, if you put gates there, there would be a way, at least for the inner harbor, to provide some protection. It doesn't do a whole lot for other parts of the city, though. This is the Dutch solution, and one that is for which the technologies are available. And in fact, there are a lot of Dutch companies that are active now in the U.S., in New York, and New Orleans, and elsewhere, advocating variations on this kind of approach, large gates that are able to close at times of storm surge. What we were suggesting as a complement or alternative to the hard infrastructure approach is what we were calling a soft infrastructure solution, which was based on the idea that one could at least dissipate the energy of storm surge by creating barrier reefs and other obstacles in the way of the surge. So, when you're looking at the consequences of a storm surge, you have to deal with the water itself filling up, but it does make a difference whether that water is coming in violently or not. And if there is a way to create obstacles in its path, then you can reduce the energy and we believe reduce the damage. Now, those obstacles in themselves can become new land, new ecologies, new facilities that in and of themselves are beneficial to the community. And so, as you'll see, I'll come back through this, but barrier reefs can be made out of subway cars. We export them now to other states and communities for that purpose, and we could use them ourselves. Oysters, which used to exist in the bay in great profusion, could be reestablished. They create a certain amount of friction. The wind turbines, in turn, can not only generate energy, but also create a barrier and an obstacle. There are ways of maybe building slips and piers that reestablish the kind of geometry that used to exist along the edges of piers, that has a roughness to it that is beneficial. And finally, islands of various scale, small ones maybe, or larger ones even, that become new wetlands to replace wetlands that are being submerged by the sea level. So a variety of ideas and devices that were being proposed as part of this. Now, back to the idea of going there in the first place. Again, the notion that motivated us was also a regional planning idea, that we could conceivably have an impact on the region that we thought might be equivalent to the impact of Central Park in the 19th century. When Central Park was conceived of and built, there wasn't a whole lot around it. It was a place in the middle of no place, in a sense, not quite, but really the void that was created that was made into Central Park, by its distinctness, created an edge which over time was filled in by the rest of the city. And so there is a constructive role for this kind of a open void, open space, public space, which can be made by land, by park, by landscape, but can also be made by water. If you think of Venice, St. Mark's Basin in Venice is a place, is a public place across which you move, from which you look around, across which you look to other parts of the city. It's very much part of the city and a place that is occupied by the people of that city. So the notion that the water is and can be a public place was important in our consideration. So we started this research project. It took us 2 years of work with students and other colleagues. My wife, again, Catherine Sievit, and a colleague, Adam Urinsky, from Architecture Research Office in New York, and colleagues in the engineering school and other departments at the university, and a lot of students. And we tried to go systematically through a process that would be an example of how you might approach this kind of research and this kind of proposal. So one thing we did was map the edges of our place, looking carefully at where we had soft and hard edges, what different kinds of say revetments or natural edges or wetlands or parks and so on, catalog and map those edges systematically as we went around. Look historically at how that edge had evolved, looking at the maps going back to the beginning of the 20th century, understanding the dynamic character of that edge. And if you think about it, the waterfront, as we often talk about it today, is sometimes considered a hard edge, but it's an edge that has never really been that hard, and that has only been hardened in the recent past, but historically has always moved back and forth, changed its character, going along through time. So, pulling that information together, we compiled an atlas, we called it, of the bay. So zooming in on all these zones around the edge, and for example, taking this cross section here, looking again what was the nature of the edge. Also getting estimating some data about the height of whatever structures there were there, none of which, by the way, is information that existed. So looking through Google and also the Microsoft version of Google Maps, I forget what it's called, that allows you to look at three-quarter views, we could estimate and scale some of the dimensions for the seawalls that existed along there. So moving around, looking up here, moving across that section, just getting this information, mapping also in the pink here and orange the flooding areas according to the 100 and 500 year maps from FEMA. All of this, this is the Gowanus Canal here, all of this to compile, again, the kind of information that would be necessary to try to do some more quantitative assessments of what we were proposing or of what the current situation is. We had a digital model that we made from the bathymetry of the harbor. So this shows the depth of underwater, very deep here at the Verrazano Narrows, and this is the channel of the Hudson coming down in the East River, and then large areas of shallow, both in front of Brooklyn here and of course in front of New Jersey. Shallow meaning about 10 or so feet. So starting to situate that underwater landscape and understand where we would want to keep the channels open, but where we could start to have interventions that would be that would not obstruct navigation or other functions. So combining that with the topography we had, we were able to make a complete map, and this was sort of one of the, as you'll see later, this was one of the conceptual developments as we move through this, is thinking of this landscape as continuous, thinking about the water as a kind of dynamic object that is sitting and moving around within a bathtub that had this shape, including the bathymetry, including the topography, as one continuous surface. And I think that was conceptually a very important part of our thought process as it evolved, because it broke down the notion of this sort of edge waterfront idea. Now, from earlier earthquake-related work that we had done, we had databases for buildings around the 5 boroughs of Manhattan, and we were able to start to superimpose the information about the building stock with the maps of flooding. And this was useful because as we could start to look at the consequences of different scenarios of sea level rise and storm surge, we could look at that against certain economic models and damage models that were based on the GIS information that we had for the city. We started to develop a little bit for New Jersey, but we didn't really have access to the same level of data that we had for New York. To do this work, one has to model the water. And so part of the work that was going on at the engineering school, Jim Smith and other colleagues there, was to develop a computational fluid dynamic model of the water that would allow us to represent what happened in the storm surge and to see what the consequences were of our interventions. So if we take this model of the bathymetry again, with water in it that can be sloshed around, and I'll show you in a second, and introduce some islands in there or some other features along the edge, we can start to try to simulate the effects of those islands. It turns out that this is a very difficult, complex fluid dynamics problem that for which the technologies are not really available. And I've had the opportunity to make presentations about this to various groups of scientists and ocean research boards of the National Research Council and so on, and we somehow hit on a science topic which everyone thinks is very, very important, but nobody has on their agenda. So that was kind of an interesting consequence of our research, and that is, how do you represent what happens when water goes on land? There's a lot of good calculation tools for figuring out, if you have a wall and there's a storm that comes in, how high on that wall will the water go over the course of a storm surge, and then you can translate that height into an estimate of the extent of flooding given the topography behind the wall. But there's no tool that really allows you to take the water onto the land and understand the dynamic interaction between the water and houses and buildings and other structures on the land. So this is an area of research that I'm trying to promote now among these various groups. So as part of our work, we did work with the Geophysical Fluid Dynamic Lab at Princeton, and a student there developed our very own hurricane based on Hurricane Isabel, moving it further north so it would track past New York, and then looking at the storm surge through our fluid dynamics model for the bay. This is the actual water surface elevation, so the amount of water in the bathtub as it fills up in the storm surge. This is the velocity, and so with or without islands, this is pink is with islands, blue is without islands. You see that the same amount of water comes in, and it's about a 3.5 meter storm surge here, but the velocity of that water is definitely diminished by the island. So in a very kind of simple way, we were able at least to demonstrate the concept that, as you'd expect, I mean, it seems fairly logical, if you put barrier reefs, then you will diminish the violence of the storm surge. So we sketched out these various scenarios, really just to communicate the idea. We did have a sort of overall plan, but we were mostly looking at the broad scale of what could be done in the context of this plan. This I think is a particularly important idea, and in fact, the Port Authority has now decided to explore the possibility of doing this, which is to build new islands in the harbor as a means of replacing submerged wetlands. The problem is, of course, with the sea level going up, the meadowlands and all the Jamaica Bay wetlands, all the wetlands that we have around New York are going to get submerged. They're also subsiding at the same time, so it's not just a sea level rise, it's also subsidence of that land. So to maintain the ecology, we have to do something about the replacement of or maintenance of some of those wetlands. If you think about, if you have a wall and there are wetlands in front of that wall, then at some point where the sea level goes up, you won't have the wetland if you hold the water at that wall and don't let it develop wetlands further inland where you can't because there are houses. Now, one of the areas of our plan was developed in more detail by Adam Urinsky and his colleagues at Architecture Research Office, and they did a very beautiful design, I think, for what the bottom of Manhattan might look like following the principles that we were proposing, which was create these island barrier reefs in front of the tip of Manhattan to protect it against the storm surge, and reconfigure the edge in a way that had much more variation and much softer conditions. And this is, I think, a very beautiful image that really captures the kind of thing that we were trying to propose. Now, the project I mentioned that the Port Authority is initiating now is really based on this idea, which is that's actually a Dutch technology, which is to take dredging material and reuse it to build land by bagging it in these geotextiles that retain some of the lower pollutants and toxic aspects of that dredge material. So it's not very toxic dredge material, but sort of I don't really know the details, but lesser, but still somewhat harmful material that can be reused as long as it's contained within these geotextile bags. So these are the sketches of what one might do with dredge material in this way, and it's, I think, an important avenue for what we're talking about, because the disposal of dredge material is a very costly process. It has to go to places that are far away from the harbor, and so if we can find ways to reuse it and those ways are beneficial, then there is an economic incentive and driver to that process. So again, these are some of the models with islands, without models that we were studying, and based on some of those results, ARO started to play around with island shapes. They did some work on a water table, studying what kinds of shapes might emerge from various just physical water table studies, and so they really tried to find form that had both the sort of organic qualities of the fluid flow, but also, in this case, had a certain relationship with the grain and fabric of the city. Catherine did a lot of work also on the ecology of the coastal tidal zones around the city, looking at what was there now and trying to extrapolate from that what might change in the future with those ecologies. So this was the design that went into the research book that was published last year on the water, which was the work of ARO. And finally, on this project, we went even to the point of proposing a whole Vaporetto system, partly because the geography of a project like this, I think, does have a lot to do with the means by which you would circulate in it. If you think about Venice and how you move around Venice on the Vaporetto, there are all different ways in which you can go around the outside of the islands or along the Grand Canal, staying on one side of the Grand Canal or bouncing back and forth. And each of the different lines has a different character. And a little bit like the subway system in New York, there are lines that go north-south, there are lines that cut diagonally. And after a while, when you live in a city that has that kind of transportation system, in your mind, those pathways become ingrained in your sense of that geography. And so I think to make this into a rich place, we thought weaving it, or at least showing how it could be woven together in this way, was part of the picture. Now, as we were finishing this research, I was talking about it with Barry Bergdahl, who is the curator of architecture and design at MoMA, and over the course of about a year and a half, he concocted a workshop and exhibition program which would build on the research that we had done up to that point. At that point, we had a book, so the background research would be available for this project, and he called it Rising Currents. And what was really interesting about this was that he constructed not just an exhibition, but a workshop that would produce the work of the exhibition. MoMA Museum of Modern Art in New York has a relationship with a museum called PS1, which is in an old school in Long Island City in Queens. And it's a very informal space that they use for contemporary art exhibitions, and every summer they have a Young Architects program where they build installations in the courtyard there. So it's a very lively, informal, and dynamic place. And so Barry had the idea that this project would start with a workshop at PS1 where 5 groups of architects and landscape architects, ecologists, engineers would go in residence for a period of time in studios there where they would produce projects that would be located in various parts of our plan. And so we went through an interview process and selection process, and we ended up with 5 young teams of architects that were each given a space to work with in our plan. This is the exhibition that resulted from that, and I'll get back to some images of that. But you can see here on the map there were 5 different locations around the bay that were identified, and each team was given one of those locations. So Lower Manhattan, which actually Architecture Research Office, the same group that had worked on the research, they took that on, and then LTL worked on the project. Louis Jermansky-Lewis worked on a project here, which I'll show you. Matthew Baird worked here, and architects worked in this area, and Kate Orff and her team, the firm Scape, worked in the area of the Gowanus Canal. So each of the team was given the research, was given access to all the digital information that we had collected, and was given a site to work with and to develop a project really on their own within the context of this general idea of transforming this place in response to climate change adaptation needs, as well as any other needs that they identified. So going around then 1, 2, 3, 4, 0, the first team worked on the Liberty Park here. So they actually took this part of the zone. This is the Statue of Liberty here in Ellis Island, and this is a park in New Jersey as it is now, very low-lying area, and proposed that a cut and fill operation transform this into a series of taller fingers reaching out into the water of all kinds of different terraced elevations with a variety of functions built in. So everything from various aquacultural and ecological research stations, parks, leisure activities, markets, all kinds of different ideas, some facilities out at the ends of these piers. You can see there lots of different functions, and completely reconfigure and completely redefine this place. You can see here in their image, this is a market space that would be accessible by water and agriculture, all kinds of stuff. And they built this quite beautiful white model, which they projected on from above and showed how with rising and falling tides, their landscape, which was terraced in the water, would transform through the plus or minus 5 feet that we get of tides over the course of the year. So very much communicating the dynamic aspect and potential of this kind of planning in the harbor, and the resilience that would come from this kind of project. Matthew Baird worked in the area between Staten Island and the Bayonne piers. In here, there's a big tank farm here. This is a main shipping channel that goes into the harbor at Elizabeth and Newark on this side. So it's a very industrial zone on one side. Here, these are the Bayonne piers that I was mentioning earlier. This is Staten Island in there. And also subject to flooding and even flooding from the sea level rise, which had to be dealt with. They chose to repurpose this area into a biofuel area with a berm built, but with some land on the outside of that berm to allow for some tidal variation there. So this turns into a different kind of facility here, buildings and so on. But they basically pulled a levee back from the edge to create a tidal zone in front and a protected area behind. And then they had this idea of recycling glass that is waste glass that is collected in New York into this is another image. Sorry, this is out of order. This is ARO. I'll come back to that. Here, that would make these glass jacks that would be put into the water and serve as a kind of coral reef protection area. So using recycling as a way of generating some of the barrier structures. These are some sectional models that they built showing the various conditions around their site. Everybody, very much taking on the notion that there's this dynamic section that emerges out of dealing with a soft water's edge. The next team working around the mouth of the harbor, the Verrazano Narrows, where the Verrazano Bridge is here. It's a very deep gulf here, which has fairly hard edges along there, and then also included this area up here. They took on the idea of building slips that allowed water to come in and also piers coming out, plus proposed a string of islands that would be along the edge here, which you see there. So small islands along that edge, which would be tied together. There are those islands, which would be tied together with inflatable barriers. So, which is a technology that the Dutch use. So you could close, you could leave it like this most of the time, but you could actually close it off in the event of a storm surge and provide protection. This you can see. So a lot of water coming in. There's a fair amount of empty lots in this area. So bringing the water in and pushing piers out as well. These are some of the images from their proposal you can see there. And it very much had a kind of Dutch character, I think, to it, of developing in the water, on the water, almost sort of hanging above the water in some of their proposals. And then finally, going around here, Kate Orff was working in front of the Gowanus area. This historically was a very shallow area here of wetlands and marshes that were built on. So it's low-lying land, and there's this canal in here which is pretty polluted, which is now a Superfund site and it's being restored slowly. So she was working in that area, but also adopted the area in front, offshore, and suggested that the oyster become a kind of metaphor for what could be done here in terms of cleansing and recycling the water and some of the pollution that is in there right now. So Kate proposed to have a new system of oyster beds built out in the shallows here. This is their shipping channel in front here, but this part here is shallow. This is Governor's Island there, which looked like that. So a kind of a net structure built on piles that would be a haven for oyster beds to be built. And she had all these images and artifacts that were part of that. What was nice about her project is also had very much the feeling and character of the Brooklyn community that it was part of. So she had a model made that was knitted in coffee shops by helpers in Brooklyn. You know, just like totally in the spirit. And then finally, ARO, that had worked on the research project before, on this project worked with Susanna Drake, the landscape architect, and together they conceived of an approach that was based on identifying a zone along the edge, which was a kind of zone of exchange. One of the things that they took on, which is important, which we hadn't really dealt with in our research, is what to do about rainfall and combined sewage outflows that happens more and more now as we get intense rainstorms, you know, like the monsoon you had today. We seem to be getting more and more of these rainstorms that come in and dump a lot of water very fast, a couple of inches sometimes. And the sewage system in New York isn't really designed to absorb that, and so every time that happens, it overwhelms and combines with the sewage, and it all goes out into the bay. So we have a big problem with that, which we're trying to clean up by building more sewage treatment plants. But another way to deal with that, of course, is through some kind of retention system. And so if you think about water flowing both ways in the event of floods or in the event of storms, of rainstorms, then there can be a kind of exchange zone, which is really what in a way what wetlands are all about, that can absorb the water in both directions, allow for quicker drainage. This is very important in flooding as well. How to get, you know, not only how do you keep the water out, but if it does come in, how do you let the water go back out again at the end of a flood, and also how you deal with that in the rainstorm. So they configured this approach, including streets that would become part of the system, and so their idea is to rebuild all the streets in this area so the streets become, in effect, retention facilities for the water and canals for the water in both directions. Again, building this kind of barrier reef stuff and soft edges, but in this case going even further and occupying in this very creative way the streets themselves. So that was the sort of the culmination of that research and the project at MoMA, and it was really quite remarkable, because if you think about it, MoMA, in this case for the first time ever, commissioned 5 groups of designers to come up with projects and committed to exhibiting those projects without ever having seen what they were like. And so there was a lot of pressure, a lot of intensity, and I think a lot of that showed in the final exhibition to get it right. And throughout the process, we had community groups come in, we had scientists come in, we had planning officials come and present, and see presentations by the teams. At some point, the teams were getting a little fed up with all the people coming in and out, not being able to get much work done. But the effect of that was that we ended up building a very strong awareness and constituency for these proposals. And now the city is developing a new waterfront plan. And Amanda Burden, who is the Director of City Planning, Commissioner of City Planning in New York, is leading that up. And as she described it, we changed the DNA of the city with this project, and she now talks about the water, as she says, is the 6th borough of the city, and the Port Authority is initiating a project to actually look at building islands. And if you think about what it takes to build in the water and how difficult it is to deal with the agencies, you know, starting with the Army Corps of Engineers and on, that are protective of those places, we did, I think, create a shift in the way that people think about that place. The last project I want to show you is from last summer. We were asked to show our original Palisade Bay project in the U.S. Pavilion at the Venice Biennale last summer in an exhibition organized by Jonathan Solomon and the High Museum of Atlanta. Michael Rooks, I think. Sorry, I blanking out, together organized this exhibition, and they called it workshopping, and it was really all about various projects that were emerging around the country out of this kind of collaborative workshop process. So obviously this, our work and the work at MoMA were good examples of that. Now the MoMA exhibition was going on, and so it didn't make a lot of sense to reproduce what was happening at MoMA, and we felt like showing Palisade Bay again at that point in parallel to MoMA didn't make that much sense. So we contacted friends at LSU, at Louisiana State University in Baton Rouge, and suggested that maybe we could collaborate on this thing for the Biennale. Of course, in its infinite wisdom, the way in which the selection process happens for the U.S. Pavilion at Biennale is that it's basically left to the last minute because they wait to see what the theme will be, which is usually announced in March or around this time of the year. And then once they have that, then they go out and solicit curator proposals. And then finally, when they pick somebody to be the commissioner, that person goes out and finds the people to actually execute it. Venice being what it is, you've got to get everything there a month and a half before because it takes forever for anything to get done. And the boats are very slow going from here to there. So between the two, you're left with about a month to get anything done. So it was a little insane, but we did decide that we were going to try to combine these two projects as sort of a next step in this project of climate adaptation design. So this was the installation. We had a video with a lot of the work from LSU. There's a coastal sustainability studio there that has been very active in developing strategies for the Delta area. And then we had some boards, which you can't see here in this picture, for our Palisade Bay project, and these two models of the Palisade Bay project and the Mississippi Delta, which I'll describe in a second, and then some boards back here that I'll show you. Catherine, my wife again, Catherine Sievert, organized the models, and we used the opportunity to try to represent what we were talking about in terms of this continuity of the land and the bathymetry and the kind of objectification of the water as an entity. And so the notion we came up with was to build these models, they're 5 feet square, representing the landform in both cases, and then hang above that the water as an object extracted out of that mold, if you like. So each of these models is the water floating above the land. So taking this continuity of land and building it into this model, the scale, of course, of the models, this being the New York Harbor and this being the Mississippi Delta, the scales are very different in the horizontal plane, but we exaggerated the vertical scale. So like in a civil engineering drawing, sometimes you have a different scale vertically and horizontally. The vertical scale is the same in both models, but the horizontal scale is different, and the vertical scale is different than the horizontal scale, so that you get a stronger sense of that topography. So these are the students working on shredding to put this model together, which was milled, actually was laser cut and glued up to create. So each of these little blocks is what is it? 15 inches square, so it's 5 by 5 feet. And here you can see this is the Bayonne Pier again. This is the mouth of the harbor. This is Manhattan down here, Roosevelt Island, the Gowanus, and so on. So you get a stronger sense of the character of this topography and bathymetry because of the exaggeration in the vertical scale. And then the water floating above that also layered up, same scale, vertical and horizontal scale as the land below, but translucent and plexiglass bolted together, and then in green showing the sea level rise and flooding plains of the water extending. So in your mind, you kind of have to combine them together, and it was fun watching people in the exhibition all have to crouch, look in that space in between, and imagine for themselves how it came together. And I think it was quite effective in getting them to think differently about this problem in this place. So that was a New York project. Going over then to the Delta, we decided to represent a proposal by an engineer scientist named Bob Twilley at LSU at the time, in Baton Rouge, now at Lafayette, who has been advocating for a strategy that he calls controlled flooding to deal with the problem of land loss in the delta. As you probably know, there's a tremendous amount of subsidence and land being lost in the delta because the Mississippi has been channeled for the last 150 years almost in the path that it goes. It hasn't been able to move around as it has done historically, and so it's not building land in the delta that it had been doing for over geologic time. So what Bob proposed is a way of redirecting the waters in different flooding situations into in this case, five different zones, so that the water and sedimentation coming down the river could, under certain occasions, be pushed into other places and used to build land in those places. So we identify these five zones. These are the Olympic colors, so this is our Delta Olympics here with these five squares. Wax Lake going from west to east, Wax Lake, Terrebonne, Barry-Lafourche, Davis Pond near New Orleans itself, and Bayou-le-Loutre over there. So again, historically, the river has moved around all over the place, and that's why the delta is the delta. But since really the Civil War, pretty much, and the work of James Buchanan Eads, it's been really going down under the tutelage, really, of the Army Corps, actually. It's been going down this channel and not providing land and sediment in the areas that it had historically before. So these are some maps of the infrastructure that exists there now, particularly all the petroleum infrastructure that's out there that includes all these facilities for getting the oil back on land. So it's not just about the nature, it's also about the industry there. So the proposal is take water and sediment from the Mississippi, redirect it in a systematic way to certain places under certain flooding situations, and use it to build land. And Wax Lake here on the eastern side, this is actually a diversion that has been built and that has been building land over time. This is taking water from the Atchafalaya and moving it into this area, and it's been working for the last 10, 15 years and working well to provide the sedimentation to rebuild some of that land. There's not a lot of water going down there at the moment, but there could be more, and it's definitely been a case study that proves the concept. Moving over to Terrebonne, you could do the same thing, taking water again down the Atchafalaya through the intercoastal waterway and then down a new channel into this area, rebuilding some of the land in there. Same in Bayou-Lafourche. This gets interesting because this bayou is what used to be one of the channels of the Mississippi. And so this proposal would be re-establishing the flow at a larger scale down that stream, which would be problematic for all the communities that live there. And so this project, in a way, is analogous to what we did for New York in that it sets the stage for a design problem that would have to be addressed, and a community design problem, really, that would have to be addressed in much greater detail to deal with all the local issues. But it works from a basic set of principles that we think establish a strategy that is worthwhile and even necessary to maintain the livelihood and ecology that people live off. This gives you a sense of the scale of what we're talking about. This is the Davis Pond, which actually exists here as a spillway, and this could be used to rebuild land down all the way down into this area as well. And that, this is New Orleans, so we're talking about quite a bit of land, even though in some of these other diagrams it doesn't seem like much. It could make a difference. And then moving to the far east here, down Mr. Go, which has now been closed, and then out to Bayou-le-Loutre in this area, taking waters from the Mississippi. So what this means is really establishing a new policy for what happens to the water of the Mississippi and the sediments of the Mississippi as it comes down through the old river control structure up here, which was built in 1928 after the 27 flood, to take by mandate, congressional mandate, to take 30% of the water down the Atchafalaya on a continual basis. So that water now is diverted, but what we're saying is that it could be diverted more extensively and some of that diversion redistributed to some of these areas according to certain kinds of rules. So let's say you have 600,000 cubic feet per second coming down, which is about sort of minimum annual flow, or 1.2 million, which is a little bit more. You know, this is the proposal that says, okay, this is where the water and the sediment would go in these different scenarios. Still 30/70, but some of it going now into other places. And then when you start to get up to higher levels, say a flow that occurs maybe every 5 years, 1.8 million cubic feet per second, still the same distribution, but again, a slightly different arrangement. And then finally, when you get into near flood conditions, 2.4 million, starting to get more of the water coming down here, and so on. And finally, with 3 million, which corresponds more or less to the 1927 flood, 50/50 going to those two channels and redistributing. So it's a dynamic proposal because it says, you know, it's not just so much water and sediment goes here on a continual basis, but it depends on how much is coming in. And it's saying, let's not just provide flood control, but let's use the floods, let's use the sediment that's brought with those floods constructively, very specifically that, constructively to good use, both to help with flood control, because you're diverting water away from where it can be damaging, but also to use that in a productive fashion. So to illustrate that, we also built a model of the delta, and you know, clearly illustrates the problem with the situation right now. The jetties that were built by Eads in the 1860s and 70s, which worked great for navigation, result in all the sediment getting dumped off the continental shelf and being useless from the standpoint of the delta. So this is the problem that has to be addressed. And so in the model representing those as those diversions as well. And the river and the depth of the river to the same scale as a series of bars. This is the Mississippi, which is incredibly deep in some of these areas, 200 or 300 feet deep. There is the landform, very beautiful. It really, changing the scale vertically really brings out the extraordinary character of the landscape. Thank you.
We have a microphone for Q&A.
Yeah, when you talked about Eads projects, you talked about some of the things that happened that perhaps Eads could not have anticipated. How is it possible, or have you thought about what are the things that might happen that these projects haven't thought about? Is it possible to try to anticipate the unintended consequences of these large-scale projects?
Mm-hmm. That's a really good question. I think starting with the very first project, the Latrobe project, there definitely was a motivation on our part, or at least on my part, to try to think big, because it seemed as if that was difficult and not necessarily welcome. So I thought it would be interesting to go there to see what would happen and what the reaction would be. And climate change, in a way, created a way to do that, because it's a problem that has to be addressed, which hasn't really been addressed yet in a very comprehensive way, at least the climate adaptation side of it. So it would bring about exactly the kinds of questions that you're asking. in the process that evolved for the MoMA workshop, I think that there was a kind of underlying notion that I had, at least, that took hold, which is that collaboration, workshopping, you know, the Biennale concept, deliberative democracy processes, community design processes, all these things are vehicles to try to get it right, or have a better chance of getting it right. So the fact that we had the workshop at PS1, that we brought in all the scientists, people that were proposing completely different approaches, had debates there, informed what we were doing, and I think strengthened the proposal because of the sort of things that you're asking about. The Mississippi proposal, and particularly these diagrams for the various flow regimes, when I was doing this, I was working with one of Bob Twilley's colleagues, Clint Wilson, who is a hydrologist, and he said, you can't do this. You know, you start showing these sorts of diagrams, people will revolt. And I said, well, I'm in New York, you know, I can get away with it. He said, well, don't let them know I had anything to do with it. And I think part of my interest was provocation as a way to begin that process with no idea that it would be implemented in exactly that way. So if you go back and you look at the Bayou, sorry, go back to this one. The Bayou Lafourche, there's communities that live all along the bayou whose houses are right up against the bayou. The bayou is this little trickle. I mean, it's not a lot. If you start wanting to put lots of hundreds of thousands of cubic feet per second of water going down there, it's not going to fit. And so you have to deal with, what do you do about these people? Well, maybe you put it on the outside. You know, maybe you start thinking of ways in which that channel is outboard of where they are and the natural levee that they live on. Maybe you explain to people that unless you do this, their livelihood is in jeopardy because of the subsidence and changes in the ecology. So you've got to engage, but you can't really engage unless you have a proposal, I think, and at some level of provocation. So I'm very sympathetic with what you're asking. I think, you know, going back to Eads, and I just finished Rising Tide, the book, fantastic book. The kind of progressive, positivist attitude that was represented by those folks, Humphreys and Eads and so on in the 19th century, doesn't apply now. But that doesn't mean we can't put something on the table that can start a discussion that may lead somewhere among well-intentioned people.
Any more questions? Let me give you this. Recording everything.
So for Rising Currents, the teams were led by architects and landscape architects.
Speak up a little bit, I can.
For Rising Currents, the teams were led by architects and landscape architects, and then you brought in ecologists and a good range of people. I'm wondering how much sort of economic impact and sort of business and economic modeling supported or was sort of part of that process?
Not. And I had hoped that some teams would be led by engineers, but nobody applied. There wasn't any kind of economic modeling going on. I think what seems to be happening with this dredging project that the Port Authority is looking at is that some of this stuff is dawning on some constituents as thinking, you know, here's something that I might actually get approval for that's going to solve my problem. So there seems to be some economic conditions that are latching on to some aspects of this as opportunities. What it would cost to do all this, I mean, the hard barriers that have been discussed, you know, are in the 10, 20, $30 billion range. So, you know, how much of this, you know, in other ways, how much of this can you get for $20 billion? as opposed to building a hard barrier. And again, you know, the ecological consequences of building a big barrier versus building a bunch of islands is you know, part of the questions. I don't even know if you wanted to how you would cost some of these things. Part of it, I was trying to allude to earlier, part of the problem is the science to test whether or not these things work isn't even there. You know, so we have to convince the NSF and others that they need to fund some of this work so that we can start to model what happens if we allow some flooding to take place, and how we deal with that. I mean, I think going back to your question, I think also there's a difference between hard infrastructure strategies, which have a tendency of getting built and then being forgotten about, and softer ones, which require a certain upkeep. You know, if you're building wetlands and stuff, they get submerged, you see that, so you have to go back and add some more land. It's more community-based in that sense, you know, like the polders in Holland that are decentralized and maintained. I mean, like the levees used to be along the Mississippi with the levee boards and so on. So centralized hard infrastructure solutions, like in New Orleans, might create the illusion of protection when more decentralized, softer approaches, which are maintained and more visible, might actually provide better protection. But how you cost all that, I don't know.
Thank you. Thank you for your presentation. Could you explain to us why are you dealing with the causes, with the effect of the climate change and not with the causes?
Why deal with the consequences and not the causes?
Yes.
Good question. If tomorrow we stop producing carbon emissions, dead, we still have a tremendous amount in the atmosphere, and there's an inertia in that process, in that system, which will lead to the kinds of sea level rise we're talking about. So, you know, we have to deal with it. I mean, I was talking to a friend who was showing me around here in Fort Lauderdale. There are areas that will be flooded because sea level is going to go up a couple of feet at least. So I think they're parallel challenges, you know, at the same time that we have to continue to find alternative energy sources, that we have to tax carbon and do all the things that are necessary. Even absolute success on that front won't change the fact that adaptation is also necessary. And I think, I mean, when we proposed the project to the Latrobe jury, the AIA Latrobe jury, whenever it was, 2007 I think it was, there was the chairman of the jury was from Charleston, and he was visibly moved by the presentation, I think, and I asked him about it later, because he'd had this anxiety and worry about what's going to happen to his community because of the sea level rise, which nobody really wants to deal with. And everybody's arguing about whether or not it's really going to happen or whatever. And so just to be able to address it in a different way was a relief. And I think that's part of why this project took hold. But it's not at all accepting the situation as it is. It's just realizing that we have to deal with it no matter what we're able to do on that front. Most of the cities you come from, right, are affected by. And how many communities have ongoing adaptation plans? Where?
Southeast Florida.
In Florida.
The 4 counties, including Broward County, that we are in Fort Lauderdale, have come together in a climate change compact to address adaptation issues.
What kind of strategies are you thinking about?
Well, they're getting the information together in terms of the projected ranges that they'll have to deal with. And they're now realizing, I think, that the first thing they'll have to deal with is stormwater and drainage. So they're looking at public facility issues, transportation issues. But they're looking at all the options, but they're also dealing with the public and public officials who are hesitant to come to grips with some of the things you showed.
Yeah.
It's very difficult.
We need a youth movement. Get all the Mubaraks out of the way.
Any more questions?
Since there are no more questions, just a comment that I think Professor Nordenson's presentation really strikes at the core of the conference, which is beyond climate change. And I want to thank you for your presentation. I think you've sort of hit a chord here with the audience. Would you agree, Rosemary? Where are you? Yeah. Thank you very much.
Thank you all.
Thank you very much. Right on target with what we were